guys, welcome to JGK Master Class. Today we will learn about rotation reflection axis, also called improper rotation, by taking the example trans 1,2-dichloroethylene, and also we will see here all the operations generated by S3 and S5 improper axis of rotation, and here we will discuss about DNH point group. So the topic is very important for all B.Sc and M.Sc students, and also for those who are appearing for NET jrf examination, GATE examination, or any other competitive examination. Point groups, symmetry elements, group theory is one of the most important topic. So I assume you already know the basics of group theory, like rotation, what is rotation, reflection, inversion, and the problems related to it. If you have familiar of all these things and point groups, then you can watch this video. So now we'll see the first problem. Define the term rotation reflection axis with an example and all the operations generated by S5 axis. So here first we will see this operation involves rotation about an axis followed by reflection through a mirror plane that is perpendicular to the rotation axis. So basically improper rotation is rotation followed by reflection, and the two are perpendicular to each other. Or you can also say reflection followed by rotation. Either way it generates, if the two generates the same result, we will be getting the improper axis of rotation. We will understand it and more clearly by taking trans 1,2-dichloroethylene example. First we will see the points. So when the result of the two operation produces an equivalent structure, means if you perform on a molecule rotation followed by reflection, or if you perform first reflection followed by rotation, the molecule gives you the same structure, means then the molecule is said to possess the rotation reflection axis. So this operation is referred as improper rotation, denoted by S, the symmetry elements here which are present, and the subscript N indicates here the rotation through 360 degree by N. So these are the points for to define the rotation reflection axis. Now we will understand it better by taking the example trans dichloroethylene. So you can see this structure which is trans dichloroethylene, and here first we are performing rotation axis. So first you have to see this is the axis of rotation along with the molecule is rotating, and whether what should be the n value that you have to see, that you should get the indistinguishable image after rotation it. So if you rotate the molecule 2 times, you get the indistinguishable image. So we can say it has C2 axis of rotation. So since we are rotating along with this axis, so along with this axis, if you rotate, the Cl will occupy the hydrogen place and hydrogen will go to the Cl place. Similarly, you can see on the other carbon, the 2 will interchange its position after C2 operation. So you are flipping the molecule 180 degree, right? And then if you put perpendicular to this axis of rotation a mirror plane here, then you can see if you put a mirror plane, you will see the exact mirror image on the other side. So this is a mirror image of this molecule. Okay, so this molecule we are getting after performing rotation followed by reflection. Now we will see here if you perform first reflection, means you are putting the mirror here first. Okay, so on performing the here again, okay, so here again you can see the example is given not first with respect to reflection, but this is the other style, means if you rotate, if you have the rotation axis, the axis of rotation like here vertical. Okay, initially we understood by taking it horizontal. Now assume the rotation axis is vertical. Then if you rotate it, hydrogen Cl will go this place and Cl H single prime will come on this place. And if we assume the rotation axis vertical, then the perpendicular will be the mirror plane. Okay, so this is a mirror plane which is perpendicular to the rotation axis. Now the mirror image of this molecule you can see here, which we are getting after putting this mirror. So you can assume this molecule is placed in front of the mirror. This is a mirror image. Now if you compare the two output here, the two structures are equivalent. Okay, so we can say the two structure are equivalent means the following molecule is having improper axis of rotation. Now, since we are talking about Sn axis, S3 and S5, so we will consider first general principle that Sn is equal to, we know, reflection followed by rotation. You can write opposite also, right? Sigma Hn Cnn. So sigma Hn is considered to be sigma H, and Cnn means it is having the identity operation. Let's assume if C33, then it will be equal to identity, doing nothing to the molecule. Identity means 1. So if you multiply 1 with any symmetry operation, it will give you the same value. So sigma H you are getting. So this rule you have to learn, and then we will apply it by taking the example S5. So we'll go S51 means reflection followed by rotation, which is C5. You cannot reduce it further. S52, you can write it like sigma H2 and C52. Sigma H2 means sigma H you are multiplying 2 times, means it will give you identity operation, that is 1. And if you multiply 1 with C52, you will get C52. S35 you can write the same way, writing 3 on superscript, and then you can say sigma H square into sigma H. Okay, you can write sigma H square into sigma H. So sigma H square is equal to identity. You can write it as sigma H and C53. You cannot further reduce this. Similarly, S54, you can write it like this, and sigma 2, sigma H2 both are identity, means 1, and C54 you can write it, which you cannot reduce it further. See, again same way we can do S55, means you can write sigma H5, C55. C55 will be what is the, you can see here, just now we have applied this rule. This is applicable for this, and we know sigma Hn, that is sigma H5 is equal to sigma H, and C55 is equal to E. So that means you are concluding with sigma H. S56 you can write like this, and again it is even number, means it will lead up with the identity, and you end up with C5 5 into C51. You can write it like C55 into C51. C55 is identity, so ultimately you will end up with C5. S57 you can write like this, and again we will end up here, so sigma H6 into sigma H. 6 is even, so 7 you will end up with sigma H. And C5H, again you can write C55 into C52. C55 is identity, so we are ending up here C52, and you cannot reduce it further. Similarly, you can do it for S58, and sigma H8 is even, identity. C58 you can write like C55, which is identity, into C53. So you end up with C53. S59 you can write like 99 here, odd number, sigma H, and here again you will end up by C54. C55 will be identity, and you cannot reduce it further. S510 you can write sigma H10 and C510, and both are even, so you can write sigma H10 is identity, C55 into C55 again identity, so end up with identity. So you can notice this is all symmetry operations are present in the S5 axis. So we can say in S5 you are having S51, you are having S53, you are having S57 and S59 in the point group. Okay, the other operations are already present into it. Next question, where they are asking for S3 improper axis and what will be the point group for this Schoenfly symbol. So first we will see same way like we have done for S5. You can notice you cannot reduce it further. C32, sigma H2 is again identity, so you will end up with C32. S33 you can write like this, and you can write here C33 is identity, and sigma H square into sigma H square is again identity, so you are ending up with sigma H. So similarly you can solve further. You can write C34 as C33 into C31. C33 will be identity into C31. Sigma H square into sigma H square both are identity, so you are ending up with C31. S35 you can write similarly, and you can further reduce it into C33 into C32. C33 will be identity, and 5 you can write sigma h square into sigma h. Square will be identity, so you are ending up with C32 and sigma h, which we cannot further reduce. So lastly we have S36, same way you can write down, both are ending up with the identity, and so ultimately you are getting identity here. So therefore we can say that S3 generates S31 and S35. All other operations are already present in the point group. So if you want to see the point group, you have to note some points here, that if you have rotation followed by sigma h, then it will generate an Sn. Means you will have improper axis if you have rotation and you have horizontal plane along with that. And in that case, we can think of the DNH point group or CNH point group. So if you look at DNH point group, you should have the perpendicular C2 axis for the Cn to have the DN point group. So we will see that. And once you say DNH point group, then these all are the symmetry operations will be present. You can notice E, Cn1, Cn2 till you have Cn n minus 1, n number of C2 perpendicular to Cn axis. You have sigma h, Sn1, Sn3 and Sn n minus 1 till you are having Sn n minus 1 for even number, and Sn 2n minus 1 then you are having at odd number. And finally n number of sigma v. Total 4n symmetry operations will be there. If n is 2, 4 into 8. Okay, 4 into 2 is 8. Total 8 operations will be there, because we have 4n operation and n is 2, 4 into 2 is 8. Okay, so since we are talking about 3 here, so 4n operation, 3 into 4 is 12. Total 12 symmetry operations should be there. You can count here 1, 2, 3, 6 and 7, 8, 9 and plus 3, 12 operations are there. What all you can just write down and see E by using the above formula. C31 and C32, since it is odd number, you have 2n minus 1 operation. Okay, 2n minus 1, that is 6 minus 1. Okay, so 6 minus 1 is 5. So C3, 5. C3, 5 will not be there for this. Okay, 3 C2, because that we have already covered under Sn operation. Then 3 perpendicular C2 operations will be there. Sigma h, S31, S35, right? So yes, so this rule which we have Sn minus 1, Sn2 and minus 1, it is applicable only for S, not for C, right? So we are having n here, Cn n minus 1, n is 3, 3 minus 1 is 2, so therefore we are having C32 here. Okay, and S31 you are having, S35 you are having here, because S33 will be identity, right? And 3 sigma v. So this is the point group for S3 axis. Similarly you can solve for S5. I hope you understood this all related to improper axis of rotation and the example trans 1,2-dichloroethylene. If you have any doubt, you can write in the description box, the comment section, and you can refer to your friend. They will also get benefit of it. And if you want me to prepare any other topic for spectroscopy or any other topic, please do write it in the comment section. Thank you.